Hello, Precalculus. Welcome to a video, the first one of mine for you guys. I like to make videos on occasion, so welcome. Thanks for watching. I wanted to make a video about this odd one out activity. Just kind of wanted to go through it a little more formally in a video. I touched on some things in class, the things that I think are the most important, but I wanted to, touch on just the whole thing in its entirety. So let's walk through this together. Okay. So the first one, we're finding the average rate of change on the interval -2 to 4. So average rate of change, as we learned, is f of b minus f of a all over b minus a. And what are we talking about when we're referencing a to b? That is the interval. So in this example, if our interval is -2 to 4, we're doing f of 4 minus f of -2 all over 4 minus -2. Well, 4 minus -2 is 6, so the denominator is pretty easy. But what about the numerator? Well, you need to plug 4 into the function, okay? So let's do that. If I plug 4 into the function, I end up getting that, right? And when I plug in -2 into the function, I end up getting, I know I'm going over into the other side, but I end up getting that. Just helping you see it written down. So let's walk through the math here. When we plug the 4 in, we end up with 4 squared, which is 16. 16 times -2, which is -32. And then -32 plus 5, which is -27. Minus, and then we do the next one. When we do -2 squared, we end up with a positive 4. Positive 4 times -2 is -8. And -8 plus 5 is -3. Still all over 6. Well, subtracting a -3 results in a +3, so you end up with -24 over 6, because -27 plus 3 is -24. And -24 divided by 6 is -4. There it is. We found average rate of change. So what does that look like for g? We're finding the average rate of change for each function. Well, what's the average rate of change of g from -2 to 4? Well, the setup is the same. And when I say the setup, I'm referencing the very beginning part of the question. The setup is the same. It's just that we're talking about g now. The setup is the same. We're just talking about g now. So when we're answering the question, what is g of 4 and what is g of -2, instead of having to plug it into the function, we just look at the table. And when you look at the table, you can see that g of 4 is -10. And when you look at the table, you can see that g of -2 is 14. 4 minus -2 is still 6. So -10 minus 14 is -24 over 6, which is -4. So these are the ones that match, making problem C the odd one out. But let's still investigate it. What are we doing here? We're finding the average rate of change from -2 to 4. Now, something that we mentioned in the notes is that the average rate of change is the slope of the line that connects those 2 points together. So here's -2. Where is the graph? Right here. Here's +4. Where is the graph? Right here. So draw a line that connects those 2 points together and ask yourself, what is the slope of that line? The slope is 0. It's flat. Okay, let's skip 2 and go to 3 and stay on this train of thought for average rate of change. Let's just keep going on that train, so to speak, okay? I'm going to skip A because I know some of us are still having troubles with inverse. Let's keep that till the end. Let's look at B. This is just me shortening the phrase average rate of change, okay? So what is the average rate of change of g of x over -3 to -2? The beginning part of the thing says to use the problems from set 1. So look back up at the top and ask yourself, what is g of -2 minus g of -3 all over -2 minus -3? -2 plus 3 is positive 1. G of -2, we're going to need to look back up at the table. G of -2 is still 14. And G of -3 is 7. So the average rate of change is 7. What about here? The rate of change of Q. Now, what I did on purpose was I didn't tell you an interval. I didn't tell you an interval. But what is true for a line? It has a constant rate of change. We refer to that as the slope. So no matter what 2 points I ask you to consider, no matter what 2 points I ask you to consider, they're all on the same line, right? Oh, I hope that's making you have an interesting thought. Like, oh yeah, like no matter what 2 points, all of the points are just on one big line, right? So when we're asking what's the rate of change, we're really just asking what's the slope of this line. And the slope is, pick a couple points that are obvious, like this one feels obvious to me here at -4, 1, and this one looks pretty obvious to me at 2, 0. So what are we doing? We're going down 1 and over 1, 2, 3, 4, 5, 6. The slope, -1/6. So again, to make you consider that if I chose this point and this point, that line is clearly different. If I choose this point and this point, that line is clearly different, right? So I need to tell you the interval -2 to 4. But again, any 2 points that I ask you to find, the line that connects them is literally just the line. Moving on. I want to try something different in the video than what I might have said in class for some people on problem A here, okay? As a reminder, the function up at the top of the page is -2x squared plus 5. I want to take a moment and remind you how to solve for an inverse function. What is f of inverse of x, right? If this is f of x, well, what is f inverse of x? Can we solve for it? Yes, we can. To find the inverse, you take the x and y and you swap them. So instead of writing y equals -2x squared plus 5, I'm instead going to write x equals -2y squared plus 5. I hope that is maybe triggering a memory for you in Algebra 2, that you found an inverse by swapping the x and y. And then you solve for y. How do we solve for y? Just relatively simple algebra steps. If you're adding 5, you need to subtract 5. If you're multiplying by -2, you need to divide by -2. And then here, how do you get rid of squared? How do you get rid of that exponent? You take the square root. And this right here is the inverse function. That right there is the inverse function, technically plus or minus. That is f inverse of x. I encourage you to rewind, run that back if you need to. But when we're talking about f inverse of x here, this is the function that we're talking about. So let's find the average rate of change from -3 to 3. So what does that look like? What does the setup look like for that? Again, f of b minus f of a all over b minus a. Well, what is f in this case? It's this. The absolute value of f inverse of 3 minus the absolute value of f inverse of -3 all over 3 minus -3. Take a minute, pause, stare at that for a second. Do you understand the order in which I've written that down? And what is f inverse of 3? Well, now that we have solved for the inverse function, just plug it in to the inverse, not to the original function, but into the inverse. Plug it in. What happens? When 3 gets plugged into here, we end up with 3 minus 5, which is -2. -2 divided by -2 is 1. And the square root of 1 is 1. And then take the absolute value, right? Well, the absolute value of 1 is simply 1. So the answer, 1 for the first one. F inverse of -3. Plug -3 into the inverse. -3 minus 5 is -8. Divided by -2, +4. Take the square root, and you end up with 2. Again, technically plus or minus 2, just like the other one was technically plus or minus 1. But plus or minus 2, but when you take the absolute value, you just end up with 2. 3 minus -3, that means plus 3, so 6. 1 minus 2 is -1/6. Whoa. And that matches -1/6 and -1/6. This is the odd one out, B. Now, what is the difficult part of this? Surely it's got to be that, right? It's finding the inverse. Once you know the inverse, don't treat the problem any differently than this one. Don't treat the problem any differently than this one. Don't treat the problem any differently than this one. We solved all of these the exact same way. It's just, what is F inverse? That's the root of the problem. Okay, so this row of work was a little bit off topic. Well, off topic from the day's lesson, right, which was average rate of change, but it was a callback to the previous lesson of concavity. The options for concavity are either concave up, concave down, or neither. And I don't mean that as a slash, that means neither. I mean that as a line. Lines don't have concavity. Well, this is the equation of a line in slope-intercept form, plus b. So this is a line. This is the equation of a line, and therefore, no concavity. It's not concave up. It's not concave down. Let's pause on B for a second, and let's look at this. Well, from 0 to 1, right, between my dotted lines there, between 0 and 1, what do you see? A line. And guess what? Lines have no concavity. Now, you might look at this table and be able to visualize it without drawing anything, but for those of us who might not be able to, let's plot this real quick. -1, 0, 1, 2, and then... So those 4 points are just going horizontal. And what I said in class and what I'll say again now is, and I'll ask is this a line? Maybe. It's maybe a line. It's maybe a line. Do we know that it's a line? No, we don't know if it's a line. Could this graph instead look like this? Of course it could. We do not know with absolute certainty what is occurring between 0 and 1. Okay? Now, if there was more clues, if there was more clues about K, well then we might be onto something. Okay? If there were more clues about K, we might be onto something. But we're not really told much. And the moral of the story here is that don't assume too much. Okay? Don't assume too much. All right? So we don't know. IDK. And that's why it's the odd one out. Because we know the answer to these, but there's just not enough. And I know that might be rubbing you the wrong way, but it's the truth. It's the truth. Okay? Okay. So I figured in this same video, I might as well flip the page here and continue looking at what's happening here on the next page, the questions that I asked you to solve. So let's look at this together. So what is true about the graphical behavior of f on the interval 11 to 12? What is being described to us? The rate of change. Something that we said was that if the rate of change is positive, the function is increasing. If the rate of change is negative, the function is decreasing. Furthermore, and I know I'm going to use some of the same words, but listen carefully. If the rate of change is increasing, then we can conclude that the function is concave up. If the rate of change is decreasing, then we can say about the function that it's concave down. And that goes back to the previous lesson, okay? So really, I encourage you again to pause, right? And look at what I'm saying. If the rate of change is a positive value, right? If you look at the rate of change at t equals 11.5, and that number is positive, that means the function, right? Rate of change and function are two different things. The rate of change and the function that we are discussing, f, are two different things. There's the rate of change of f, and there's f itself. They're two different things. So we are being told that the rate of change of f is negative. So if the rate of change is negative, then what does that allow us to conclude about f? That means f is decreasing. And if the rate of change is increasing, right? The rate of change is still a negative number, but the rate of change is increasing. Again, what does that allow us to conclude about f itself? That the function is concave up. So think about that for each of these. Positive and increasing means f is increasing and f is concave up. Negative means f is decreasing but still concave up. If it's positive, it's increasing now, and if the rate of change is decreasing, that means it's concave down. If it's back to negative, it's decreasing, but if this is still decreasing, then the graph is concave down. And again, I know it's tough. You're like, you keep saying like increasing and decreasing. It's like, I can't keep track. That's because there's two separate things that we're discussing. The rate of change of f and f. So what does increasing and concave up look like? What does decreasing and concave up look like? What does increasing and concave down look like? What does decreasing and concave down look like? Could this be the graph of f? Yes. Yes, it could. It is increasing in concave up. It is decreasing in concave up. It is increasing in concave down. It is decreasing in concave down. Think about the change that is occurring. This is a typo. I'm hoping some of you just assumed that I meant 11, but if not, whatever, I forgive you. Doesn't matter. So think about the change that is occurring at x equals 11. How could you describe this point? If you could sort of like, what's the vibe that you're getting here? Well, how would you describe this point up here? Especially in comparison to the stuff around it. Compare that point to the stuff around it. At x equals 11, that appears to be like there's something special at the top, right? And then I asked you in the next one, is the same thing happening at x equals... Wait, did I make a mistake with my drawing? We were supposed to end on 15. How did I not end on 15? 10 to 11, increasing. Yeah. 11 to 12, decreasing. Oh, wait, this went from 12. Oh. This should have been 12 to 13. And 13. Gosh dang it. Okay, well, I'm discovering issues with my... I'm sorry. Okay. I'm sorry. Well, I'm glad I'm making this video and making this discovery, but when I collect this, I'll just have to ignore that. Anyway, if you're watching the video, I very much appreciate you. And let's address what is happening at 11 and 13. Compare these two things. What are they? Is there a word that you think you could use? Maybe pause and think. What are they? I'll just let you hold on to that for a second. Oh, we're switching problems. Okay, I won't let you hold on to it for a second. What's happening there? They both appear to be a maximum of some kind. They're both high points. They're both high points. And think about why that is. What is making that a maximum? It's because, well, look at the table. What is the same? Look at the transition from here to here. And look at the transition from here to here. What is happening? This is increasing, or sorry, this is positive increasing, negative increasing. This is positive decreasing, negative decreasing. So what's the same about those? Well, these match, but these are different. These match, but these are different. Okay, what's happening there? What's so significant about these being different? Because the rate of change is going from positive, which means it's increasing, to negative, which means it's decreasing. So logically, this has to be the highest point, right? If you were going up, and then all of a sudden it told you to go down, 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 well, then wherever you just were is going to be a peak. It's going to be the top of this theoretical mountain, right? If you went from increasing to increasing, right? That just means you keep going up, right? So this isn't a max, it's just a point. But to go from increasing to decreasing, Right? And the same thing happened here. Okay, this video is getting kind of long, probably longer than you're liking, but if you're still with me, wow, you're a true rock star. Determine the rate and concavity of h of x on the interval 0 to 2. What is the concavity? And write a complete justification, the rate and the concavity. So this goes back to those really formal things that I had us write in class. So for concavity, this hopefully you can see that this is concave up. And so on 0 to 2, yes, h of x is concave up. But why? Because the rate of change is increasing. Okay? That's the why. That is the why. And what is it also doing? It is decreasing. The rate is decreasing. Okay? So h of x is decreasing on 0 to 2 because, and then let's see if I can remember the inequality. Because for any a and b on 0 to 2, if a is less than b, then f of a is greater than f of b. Because what are we saying? The point on the left is higher than the point on the right. Right? If I'm drawing, here's a point on the left. As long as I make the point on the right a little bit lower, it'll be decreasing. That's what we're saying. Okay, let's go ahead and call it there. I really hope you watched me do all 9 of these problems, but if you made it to the very end, what a true rock star. I appreciate your viewing, and man, I'll catch you later. Peace out.